Now, let's see. Can you understand how to mix a solution and calculate its concentration in molarity? So this is a PhET simulation having to do with molarity. And I want you to notice here solution concentration, which is in the unit of molarity. So how can we have a high solution concentration? Well, let's try this. The solute versus solvent. What if I add more moles of solute? And what you'll notice is that did, in fact, increase the concentration. But can we make it even more concentrated? So you need a lot of solute. What about solvent, the amount of the solution? Well, if I increase it, oh, no, that's going to decrease my concentration. So I have a lower molarity. So let's go the other direction. If I lower the amount of the solution, all right, so now what does it take to have a high concentration or a high molarity? It takes a lot of solute and a very little bit of the solvent. So concentration, it's a measure of the amount of solute in a solvent. If you think about it quantitatively, like quality, so describe it without numbers, then, for example, it's a hot day outside. That's qualitative observation. So if you have a concentrated solution, you have a large amount of solute and a small amount of solvent. If you have a diluted solution, very watered down, you have a small amount of solute and a large amount of solvent. If we think quantitatively with numbers, for example, instead of just it's hot outside, we can say it's 85 degrees outside. So concentration in number form is represented by molarity, which is a term used to describe the quantitative concentration of solutions. The formula for molarity is the moles of the solute divided by the total liters of the solution. And so in short, molarity has a symbol of capital M equals MOL for moles of solute and capital L for liters of the solution. So molarity is moles divided by liters. If you're given grams, though, because in real life we don't measure things on the balance in moles, we measure them in grams. So we tend to need to measure out how many grams we need to create our solutions. And so you need to be able to convert your grams to moles. So we use the molar mass in the periodic table to change from grams to moles. Take your grams, divide them by the molar mass in the periodic table, and then you'll have moles. And then you can place that in this equation at this point right here. If the question asks you 4 grams as your final answer, you're going to calculate the moles, and then you're going to determine the amount of grams using the molar mass in the periodic table. If they give you the volume in anything other than liters, you're going to have to change it to liters. So for us, we're generally only going to be given it in milliliters and then convert it to liters by dividing by 1,000. So milliliters divided by 1,000 is going to equal liters. So now we'll do some example calculations of molarity. Number 1, if there are 0.500 moles of sodium hydroxide and 1.00 liters of solution, what is the molarity of the solution? So our equation is molarity equals moles divided by liters. And if we look in the question, they tell us what is the molarity. So I'm going to call that my X equals, and then they give me the amount in moles. So I'm going to put that at the top here, 0.500 moles. And then they also tell me the amount in liters, so I'll put that at the bottom here, 1.00 liters. And so this becomes a very easy calculation where we take 0.5 divided by 1.00. So X is going to equal 0.500. And then X is molarity, and so that's a unit of capital M. So this is my final answer for number 1. How many moles of potassium hydroxide are in 0.50 liters of a 0.10 molar KOH solution? So capital M we refer to as a molar concentration. So when you hear me say molar, that's really molarity, but for short. And so my equation again is molarity equals the moles divided by the liters. In this case, they said how many moles. So this is what my X is going to be. I'm looking for the amount in moles. And then they tell me the liters, so that's going to go under my moles. So X moles, and I have 0.50 liters given to me. And then my amount in molarity is 0.10 molar. And so now that I have this information right here, we can solve for x. You can place your molarity over 1, and then from this point, you can cross multiply. And so it's going to be x times 1, which is just x, equals 0.10 times 0.50. And when we multiply these, we get x equals 0.05. Remember, x is moles. And so we just found the amount of moles of solute in this solution. What is the molarity of a solution if 80 grams of sodium hydroxide is in 1.00 liters of the solution? So as per before, the equation is molarity equals moles divided by liter. And what we'll notice in this problem is that they want us to figure out the molarity, so that's my x. And then I want to put the moles at the top and I want to put the liters at the bottom. Well, we do have the liters, 1.00 liters, but I don't have the moles. They gave me grams instead. So with grams, we're going to change grams to mole. And you can just take the amount of grams, 80.0 grams of NaOH, and you can divide it by its molar mass in order to get the moles. So to get the molar mass, we're going to have to go add up each of these from the periodic table. And so sodium is 22.99, oxygen 15.999, and hydrogen 1.008. So we have 22.99 plus 15.999 plus 1.008. And so when we do this math, we're going to get, for this molar mass down here, 39.997. And then we're going to do 80 divided by that value to get our amount in moles, which will be 2.00 moles. That is the value that's going to go here in order to help me solve for my molarity. So we'll put our 2.00 moles up here, divide that by 1 liter, and of course that is going to get us x equals 2. And then remember, we just solved for the molarity. When you do moles divided by liter, you get the molarity. So we get 2 molar as our solution concentration. Finally, this is our last molarity calculation. We have molarity equals moles divided by liter. And so now let's read the question. It says, how many grams of calcium chloride would be required to produce 2.5 liters of a 3.5 molar solution? So I have my molarity, that's 3.5, equals, I also have my liters. They tell me it's 2.5 liters, and what I don't have is the moles. So I don't have this. However, they don't want my final answer to be moles, they want my final answer to be grams. So what we're going to do is we're going to solve for x, and that's going to give me x in moles, and then I'm going to have to change my final answer from moles to grams. So first let's solve for the x. We're going to just place this over 1, and we're going to cross multiply. And so that's going to look like this. X times 1 is x equals 3.5 times 2.5. So x is equal to 8.75. And that is moles, because what we're solving for is the moles in this problem. Now that I know how many moles I have, I want to figure out what is that in grams. And so to convert to grams, you're going to take your moles, and we're going to multiply times the molar mass from the periodic table. And so I need to go look up the molar mass of our compound, which is CaCl2. So calcium has a mass of 40.078, and chloride has a mass of 35.453. So we'll say 40 plus 35.5 times 2, because there's 2 of them in the formula. All right, let's do some simplifying. We're going to get 8.75 times, and when I do the math here, I get about 111. That's going to be grams per mole of calcium chloride. And so when I multiply those two numbers together, I'm going to get 971.25 grams of CaCl2.